Okay, let's look at this question from November 2019 on work, energy, and power. This is quite a straightforward question. It says, to an object of mass 1,8 kilograms slides down a rough curved track and passes point A, which is 1.5 meters above the ground, at a speed of 0.95 meters per second. The object reaches point B at the bottom of the track at a speed of 4 meters per second. Then it says to define the term conservative force. So conservative force is a force for which the work done in moving an object between 2 points is independent of the path taken. These forces that conserve energy, they are usually non-contact forces. So the conservative force acting here is the gravitational force. Okay, so we call it the gravitational force is the most correct way to call it. Then it says to you, is mechanical energy conserved as the object slides from point A to point B? Choose from yes or no. So when is mechanical energy conserved? It's only conserved in an isolated system where there are no non-conservative forces. But now here, this thing says to you, it is a rough track. So mechanical energy is not conserved, no, because the system is not isolated, or you could say friction is present or a non-conservative force is present. So you can like say friction or a non-conservative force or the non-conservative force of friction, so long as you say no and that you point out that there's something that is going to take energy out of the system. Then it says to you, calculate the gravitational potential energy of the object when it was at point A. So gravitational potential energy is given by this formula, EP equals mgh. So what will the potential energy be? It will be the mass, 1.8, times the acceleration due to gravity, which is 9.8, times the height above the ground, which is very handily given to you here as 1.5 meters. So this amount of potential energy is something like 26,46 joules. Okay, if you put that all in your calculator. Remember, energy calculated in joules, no unit, no mark. Then it says to you, using energy principles, calculate the work done by friction on the object as it slides from point A to point B. So over here, if we want to calculate the work done by friction, it is a non-conservative force. I don't see any other non-conservative forces acting on this. So you could use net work, or you could use this non-conservative work formula. I like to use the non-conservative work formula. So here's the non-conservative work formula. So the work is going to be equal to the change in kinetic energy. So kinetic energy is a half mv squared. So the change is a half mv final minus initial, both of those squared. So this is a half of what was the mass of the box, was 1.8 kilos. And then it's times the final velocity. And now look here, this box was speeding up. Okay, so this will be 4 squared minus, what was my initial speed? If you have a look here, it's 0.95 minus 0.95 squared. Make sure that the squared is inside the brackets, because if the squared is outside the brackets, you will run into a huge problem. It is the final velocity squared minus the initial velocity squared. Okay, and then it's plus the change in potential energy. So potential energy is mgh. So the m was 1.8, and then g is, as always, our friend 9.8. And then now it will be the final height minus the initial height. But now the ground is our zero reference. So my final height is 0, and my initial height is given here as 1.5. So, or you do actually know that your initial energy here is this 26,46. So you could actually have written here 0 minus 26,46 in this equation, because remember you calculated its potential energy here. So you could have just put in the final potential energy as 0 minus 26,46. You would still be fine. and then you come out with your work done. Your work done is minus 12,87 joules. Okay, why is this minus? Because friction is a non-conservative force. It is taking energy out the system, so this answer is negative. Remember, work is a scalar, and this minus is indicating that work has come out of the system. Then it says to you, surface BC in the diagram above is frictionless. So if there's no friction, there can be no non-conservative force here. Then it says to you, what is the value of the net work done on the object as it slides from point B to point C? Now, if the object is frictionless, there are no other forces acting on this to change its velocity. So net work is the change in kinetic energy. The kinetic energy will not change if there's no friction. So there's going to be absolutely no net work done on here. So there will be 0 joules, no unit, no mark, 0 joules of net work done as this object slides from point B to C, because there are no non-conservative forces present.